G'day there, Level 2 Physics. This is a quick little video to teach or remind you about how to use trigonometry. And the reason we would use trigonometry in physics is to split vectors into different components. And the reason that we have vectors is because in physics we have quantities that don't just have a size, like mass just has a size, but that have a direction too, like force, like a push. Can't push something without a direction. Try it if you don't believe me. And so the really important rule that I want you to remember is that any vector we can redraw as two other vectors at right angles to each other. This rule is going to underpin your solution to many problems in years to come. And so we've got 100 meters per second. Turns out velocity is a vector. You have to have a direction when you're moving. And 20 degrees counterclockwise from north. And so we're going to split that into a component that's north and a component that's west. And they look like this. So the first thing I've done is I've drawn a triangle that has split my original vector into two other vectors, and I've labelled them Vy, the y component of the velocity, and Vx, the x component of the velocity. And it turns out that a body moving at 100 meters per second that way is the equivalent to a body that moves at Vy that way and Vx that way. And so we're going to use trigonometry to work out the size of each of those components. The first thing that we need to do is label the sides of the triangle, and hopefully you can remember that the long side is called the hypotenuse. The one that's opposite the angle is called the O, and the leftover one, the one that's next to the angle but it's not the hypotenuse, that's called the adjacent. So we use A. And so HOA. First thing, label your three sides. Then we need to remember that little ditty, silly old Henry caught a hapuka trolling off Awaroa. That helps us remember which of our trig functions are associated with which solution. And so if we're trying to find the y component, we're trying to find the a, we know the h, a and h, it's the c1, it's cos. And so what does that c-a-h thing mean? What it means is cos theta equals a over h. The c stands for cos theta, a stands for a, h stands for h. Rearrange, we're trying to find a, so rearrange for a. A is h cos theta, 100 cos 20, 93.97, so our Vy is around about 94 meters per second. Let's have a go at doing the x component. If you think you can do it, pause the video and do it, then check back in a second to see if you got the right answer. Otherwise I'm going to do it for you now. So, the first thing we did was we looked at which component we wanted to find, Vx, and we know that it's the O side. We know that h is 100, O and h leads us to SOH, sin. Sin theta equals O over h is what that means. And so rearrange it to make it O is h sin theta. O is 100 sin 20, 34.2. So Vx is around about 34 meters per second. Which leads us to the interesting discovery that 100 is the same as 34 and 94. That's interesting, isn't it? So don't expect the two components to add to the resultant. They don't.